Alright, this is question 5 of homework 2. This question right here. So, for question A, we're asked about the magnitude, about the displacement needed to get the ball in the hole in just one putt in a due direction east. So, first we're given 3 different strokes, or putts. And the thing is, they're all vectors. So the first putt, it's just a vector of x is 0, and y is 3.28 meters because it's 3.28 meters north. The other two are a little bit more complicated. We got 1.6 meters southeast and 0.8 meters southwest. South is just negative y. East is just positive x. So that's why I have this written right here. And for here, west is just negative x and south is just negative y. So let's turn this into, let's try to figure out what x and y is for these two. So right here, I essentially say that southeast means it goes just as much south as just as much east. And if south and east are just as much, that means x and y are the same. Or in other words, the absolute value of the change in x and the change in y are equal. This is the number one thing you need to realize when they say southeast or southwest. That absolute value of x and y are equal. Because now if we were to draw these two vectors out, if they're equal, these angles will make a 45, 45, 90 triangle. So, using this information, we can figure out the x and y components of each vector. So let's apply this to the first of 1.56 meters southeast putt. So we already know what c squared is. It's a 1.56. And we know that x and y is the same, or in this case a and b. So instead of using c squared equals a squared plus b squared, I turn it to c squared equals 2 times a squared because a and b are the same. So then we just plug in 1.56 as c, and we try to figure out what a is. And we figure it out. If you go through the work, a would equal this. And recall, southeast is a positive x and a negative y. And since a and b are the same, because it goes just as much south as it is east, the southeast vector can be written like this. Perfect. And then if we do the exact same thing for the southwest vector, we get this. Here's the work. So now we can add all 3 vectors. Very simple. Just add the numbers up on the x and add all the y's. So this is the total magnitude. But this is just the x and y we want. So now we have to use the Pythagorean theorem again. But this time we know what a is and we know what b is. And if we go through the work to find what c is, we will get this, which is the correct answer. 1.617, 1.616, very similar. And then for b, they're asking us what the angle between the direction of displacement needed to get into the hole in just one putt in the direction due east. Due east just means positive x direction if you think about it, because north is going up, east is this way. So if we draw out our total magnitude, because we already got it, this is the y component, 1.59 meters. This is the x component, 0.5161 meters. And then put in the total magnitude that we got from the last question right here. We have this drawing, and it doesn't matter which order you put them in. And we want the angle of due east. So we want this angle right here, because this is on the x-axis. So we want to find this angle. There are many ways to find this angle. You could use law of cosines, or you can just use arcsine, which is just arcsine over 1.59 divided by this angle, and you will get the right answer of 72.013. or something very, very close to that.